Well, dear students, I welcome you to this session where I'll be discussing about the recombination of colors. Yesterday we studied the dispersion of light and what exactly is the difference between pure spectrum and impure spectrum. Today we are trying to prove that white light is made up of 7 different colors. What is the experiment I am going to perform? To perform or to prove that white light is made up of 7 different colors, I make use of two prisms. How is it, or how I use these particular, how exactly I use these two prisms? I place one prism as usual and the other prism I keep it inverted as I show now here in the figure. Now you'll be able to see that ABC is one prism, A dash, B dash, C dash is another prism kept inverted. I pass white light through the first prism. What happens? Dispersion of light takes place and dispersed light comes out of the first prism. And when this gets into the second prism, all the colors will fall back on themselves, as a result of which the original composite light emerges out of the second prism in a path parallel to that of the incident beam. And this proves that white light is made up of 7 different colors. For the last time, I will be repeating the same thing there. I make use of two prisms here. One of the prisms is kept as usual. The second prism is kept inverted as I've already shown in the figure. I pass white light to the first prism. What happens? Dispersion of light takes place. Pass this dispersed light to the second prism. The dispersed light, while getting into the second prism, all the colors will fall back on themselves, as a result of which original composite light will be formed there, and it emerges out of the second prism in a path parallel to that of the incident beam. You must support your answer with a beautiful figure. And then I just take the natural phenomenon. What is that natural phenomenon that occurs in nature? The formation of a rainbow. How exactly a rainbow is cast? It is also once again here, water drops act as prisms there. Once again, what happens? Here you find two phenomena of light. You must know that. Two phenomena of light you are going to see during the formation of a rainbow. Here, when actually sunlight enters the water drop, it disperses into 7 different colors. But you must know that when it just enters and falls on the other side of the film there, water drop there, other film there, it just falls on that one at an angle more than the critical angle. That's a very important thing there. It incidents on the other side of the water drop at an angle more than the critical angle. If a ray of light incidents at an angle more than the critical angle, all the rays will be totally internally reflected. That means it undergoes total internal reflection of light, as you see here. Now see that now sunlight is entering the water drop now. The light just gets dispersed now. Water drop acts as a prism here. It disperses white light into 7 different colors. Now these colors are incidenting on the side or let's say on the inner side of the film again at an angle more than the critical angle. Therefore, total internal reflection takes place and it just gets out of this one water drop and a rainbow is cast as I have shown here. Therefore, the two phenomena of light that you see here is the first one, dispersion of light, that is refraction of light. Number two, total internal reflection of light. They are the two phenomena of light that you observe during the formation of rainbow. What are the two phenomena of light? The first one is dispersion of light or refraction of light. The second one is total internal reflection of light. They are the two phenomena that you observe during the formation of a rainbow. I hope you have understood this one. And next one, uh, we will just take up a number of questions here. Now here, why is or you see the sky. The sky appears blue. Why exactly it appears blue? It's a very important point there. Now, the atmosphere is made up of air particles, fine particles, that is, colloidal particles are present in the atmosphere. Colloidal particles are capable of scattering light. That is one of the properties of colloidal particles. Colloidal particles are capable of scattering which one? White light. The color of the light depends upon the size of the colloidal particles. If the particles are very small, then blue color gets scattered. Blue color gets scattered. If the scattering particles are larger in size, then red light gets scattered. You must know that one. And if the particles are of very big size, then no scattering of light actually takes place and white light only gets scattered. White light only gets scattered. And that is how you see that one. What happens? The sky appears blue. You must know that one. Sky appears blue. Why? Because the wavelength of a blue is very small. It is short. It is actually 1.8 times lesser than that of which one? The red light. And therefore, the blue color of white light gets scattered in the sky. Therefore, the sky appears blue. That's the reason. That is, very small colloidal particles, they scatter blue color of white light. That is, they are very small in size, and therefore they are capable of scattering blue color only, and the blue color of white light just gets scattered, it appears blue. I hope you understood. Then, coming to the other aspect, why do stars twinkle? Twinkling, twinkling, little star, how I wonder what you are. You might have already heard that poem when you were very young. Okay, that's the first rhyme that you have learned. Now, I would like to just explain to you why exactly stars twinkle. Stars are point objects. Why are they called point objects? They lie far away from us, very far away from us. Therefore, they appear as small particles. Therefore, they are referred to as what you call point objects. The light coming out of the point object now, it undergoes refraction at various levels of the atmosphere. See, you must know that the atmospheric air has got different densities. You must understand that. As you just go higher and higher, the quantity of air present there, it actually varies. And density also varies. When just light from which one? Very far off objects, point objects, they enter into atmosphere, they undergo refraction number of times by various layers. And therefore, what will happen? The position of the position or the path of the light varies before reaching our eye. It goes on. Therefore, the position of the star also appears to what shall I say vary, and therefore the light that enters our eyes actually appears to be a twinkling light. That's all. That means because they undergo atmospheric refraction at different levels, certainly what are the path of the rays actually vary, and therefore the position of the star also varies, and therefore the light that reaches our eyes will appear to be twinkling. That is how stars twinkle. But with respect to stars, they are not so far away as stars, and they may be considered as linear objects, and therefore though the light undergoes refraction flight, it doesn't go refraction so much, and therefore you don't find that planets actually twinkle. Planets do not twinkle. stars twinkle. That is the difference between stars and what shall I say? Stars and planets. Okay, you have understood this one. Next one. A diamond sparkles. Am I right? I think so. The sparkling. Why does diamond sparkle? When light just falls on diamond, you must know that you must understand this particular point is a very important point there. When you see diamond in the nature, it will not be sparkling piece. You must cut the faces and you must polish the surfaces. You must cut the diamond in such a way that you just get the polished surfaces. It is a skillful art. It is actually cut in such a way that as much as total internal reflection of light takes place, therefore it sparkles. You must know that diamond sparkles on account of the total internal reflection of light that takes place within diamond. Actually the faces are cut in such a way that as much as total internal reflection of light takes place, and therefore a diamond sparkles. That is, you must know that is how it is called a brilliant. It is called a brilliant. And you must know that diamond is cut and polished in such a way that as much as total internal reflection of light takes place, so that it becomes a shining crystal, and that shining crystal is referred to as a brilliant, and that's how a diamond sparkles. I think you have understood all these things there. Thank you very much. We'll just take up something more in the next class, that is about refraction of light through a lens. But before we just take up, we can just take the introductory note, that is, what is a lens? What is a lens? Lens. What is a lens? You must understand. Now I would like to just take up this one. Now I'll just take two circles, let us say. Now before you only, I draw two circles. Two circles, intersecting circles I have just taken. See that. In the very first instance, I have taken two circles, intersecting circles. I'll shade the part here. It's like this. You see that? You take the shaded part. It's a lens. Now I just take two touching circles, or two circles that may be drawn very close to each other. Now here I just shade this portion. It's also a lens. You're able to see that? One intersecting circles ತೊಗೊಂಡೆ, non-intersecting circles ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. I have got two lenses now here. Whatever may be the thing there, lenses means it must have two curved surfaces. Lens is made up of two curved surfaces. That is the first point. Number two, it is made up of a transparent substance. It should be made up of glass. Therefore, what is a lens? Any transparent substance, please understand. Any transparent substance bounded by two curved surfaces, at least one, capable of refracting light. Again, I repeat, what is a lens? Lens means any substance, any transparent substance bounded by two curved surfaces, bracketally at least one curved surface ಇರಲೇಬೇಕು. ಇನ್ನೊಂದು ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ಇರಬಹುದು. Therefore, once again I repeat, any transparent substance bounded by two curved surfaces, at least one, capable of refracting light, is called a lens. There are two types of lenses. One is called a convex lens and another is a concave lens. Now comes the question, how to distinguish between a concave lens and a convex lens? Now, in the case of a convex lens, you must know that it is bulged out at the middle and thinner at the edges. And in the case of a convex mirror or convex lens, in the case of a convex lens, it is bulged out at the middle and thinner at the edges. But in the case of a concave lens, it is bulged out at the edges and it is thinner at the middle. You can see that. Here I have written. Here I have written. Yeah. You please see that one. It is thicker at the middle and thinner at the edges, and a concave lens is thinner at the middle and thicker at the edges. That's how we can distinguish between a concave lens and a convex lens. Once again, for the last time, repeating the same thing there. Any transparent substance bounded by two curved surfaces, at least one, capable of refracting light is called a lens. There are two types of lenses. One is a concave lens, another is a convex lens. Convex lens is bulged out at the middle and thinner at the edges, or thicker at the middle and thinner at the edges. And in the case of a concave lens, it is thicker at the edges but thinner at the middle. That is how we can distinguish between a concave lens and a convex lens. And tomorrow I will be able to just take up the action of lens, how exactly refraction takes place in the case of a lens. Thank you. Bye.